Hello, for today's project, we'll be going over trig functions and right triangle trig ratios. To start it off, essentially what a trig function is that it sets an angle of a right triangle um, and sets it equal to two sides of that triangle. So like a ratio, if you will. Um, and when going about solving trig functions or ratios, you can either use the unit circle definition, which what we have here, or just the standard SOHCAHTOA way. So for our first expression here, we have y over 1, and the unit circle definition states that the y-coordinate of a triangle is basically the sine of theta for that triangle. And the x-coordinate of that triangle is the cosine of theta. So y over 1 is just the same thing as y, and knowing the unit circle definition, y is just the sine of theta. So this would just be sine. And it just so happens that x over 1 is the same thing as x, and that'll be cosine as well, cosine of theta rather. Yeah. However, if you want to use the SOHCAHTOA way, we must list the sides. So this side would be y, and this side would be x, since the coordinates are listed right here. Also, there's a coordinate plane, so this side is the x-axis, this side's the y-axis. And knowing that the unit circle radius is just 1, we can say that the hypotenuse is 1 as well. Therefore, for solving this expression right here, y is just the opposite of theta, and 1 is just the hypotenuse of this triangle. So knowing that, the opposite over hypotenuse, that is sine, and that's how we got sine. And same thing with the cosine. X is the adjacent to theta, and 1 is just the hypotenuse. So adjacent over hypotenuse is cosine. Moving to our next one, we have y over x. Knowing that y is the opposite and x is the adjacent, we can say that it's tangent of theta. For our next expression, we have b over c. So that is referring to this triangle since it has sides b and c. And we have theta right here. And b is the opposite of theta, and c is the hypotenuse. So opposite over hypotenuse is sine of theta, and we have a over c. A is adjacent to theta, and c is the hypotenuse. So adjacent over hypotenuse is cosine of theta, and for lastly, b over a is just the opposite over the adjacent. So opposite over adjacent is tangent of theta. Now we have been given the trig function and we're supposed to find the ratio. So sine of angle ABC, which is theta. And using the unit circle definition, sine of an angle is just y over 1, y over 1. But this is for this triangle. This is a unit circle definition for this triangle. However, we cannot put y over 1 as our answer since we're focused on this triangle, triangle ABC. Um, However, knowing that these two angles are the same, we can use our previously solved answers, which is right here. We have y over 1. So sine of theta is y over 1 or b over c. And b over c is relating to this circle, or triangle rather, and which is what we want. So sine of theta is b over c. And we can just say that this is sine is b over c as well. That just shows how these two triangles are correlated with one another since they have the same angle. But obviously, we could use SOHCAHTOA as well, which is sine of this angle. Sine is opposite over hypotenuse, b over c, and that's how we got that. Moving over to our next problem here, we have cosine of angle ABC. Um, so we have theta, ABC, angle ABC, basically theta, and cosine states that it's adjacent over hypotenuse, which is A is adjacent and C is the hypotenuse, so A over C. And for our next problem, we have tangent of angle ABC or theta, and tangent states that it's opposite over adjacent, and B is opposite from one another, and adjacent is A since they're right beside it, so that'd be B over A.